A car is driving on a straight road. Its motion is shown in the graph on the right. How far does the car travel between 0 seconds and 50 seconds? Here's another question involving motion graphs, so let's take a look at the graph. The horizontal axis is time in seconds, and the vertical axis is velocity in meters per second. So we have a velocity time graph. The car is driving on a straight road, and we can see its velocity starts at 20 meters per second, then it slows down to 10 meters per second, and stays there for a bit, and then it speeds up to 20 meters per second. The problem is asking us to find how far the car travels between 0 seconds and 50 seconds. So we're trying to find the displacement of the car over that time period. How does displacement relate to this graph? Displacement is the area under the curve of a velocity time graph. If we were using calculus, we'd say that the displacement is the integral of the velocity with respect to time. So we need to find the area under the curve between 0 and 50 seconds, which is the area between the curve, or the line, and the horizontal axis. There's several ways we could split up this area, but we're going to use these two triangles and this rectangle. Since all the information is in the graph, we won't bother writing anything in the given information box, but we'll write that we're trying to find delta x between 0 and 50 seconds, which we know is the area under the curve between those two times. Let's also write the equations for the area of a triangle, 1/2 base times height, and the area of a rectangle, which is just base times height, or length times width. We can find the base and height of each one based on the graph, and then add the areas together. So let's start with the first triangle. The base of the triangle would be 20 seconds minus 0 seconds, and the height would be 20 meters per second minus 10 meters per second. That gives us 100 meters for the area of that triangle. Now let's do the second triangle between 40 and 50 seconds. The base is 50 seconds minus 40 seconds, and the height is 20 meters per second minus 10 meters per second. That gives us 50 meters for that area. Now let's do the rectangle. The base is 50 seconds minus 0 seconds, and the height is 10 meters per second minus 0 meters per second. And we get 500 meters for the area of the rectangle. Now we just add up all three areas, 100 meters plus 50 meters plus 500 meters, and we get 650 meters for the displacement of the car between 0 and 50 seconds. So does that answer make sense? The velocity is positive the entire time, so the displacement should be positive. And the unit is right for displacement. One way we could solve this differently and check our answer is to use some of the kinematic equations and points from the graph to split up the motion and solve for the displacement during each period. But when we're given a motion graph and we can use the slope or the area under the curve to answer the question, that's usually the method we'll use.